So let's look at the relationship between these two circles. What can we say about the relationship between these two circles, the way they are?
Internally tangent.
Internally tangent. Now when they are internally tangent like this, can you see the radius of the bigger circle, the pink one?
Yes.
So make that a capital R. This a capital R to show the radius of the bigger circle, and look at the radius of the smaller circle, the white one. So I put radius of the smaller circle. Now look at the distance between the centers of the circles. Can you see? This is the center of this circle and this is the center of this circle. When they are internally tangent like this, what can we say the relationship is between the radii of the two circles and the distance between the circles? Let me show the distance between the circles here. This is the center of this circle and the center of this circle. Can you see right there the distance?
Yes.
Okay. So what can we say about the distance in relation to the radii of the two circles? How do we get this distance? It will be
R,
this radius of the bigger circle minus
the smaller
radius of the smaller circle. Then we are going to get this distance, the distance between the two circles. So I'm going to put that. So looking at distance, if we make a distance the first term of comparison, we say when the circles are internally tangent, the distance between the two circles equals the difference between the longer radius and the smaller radius. Can you see that?
Yes.
Now suppose I make my radii my first term of comparison. What can we say the relationship is between the radii of the two circles and the distance?
The radius of the big circle minus the radius of the smaller circle equals to the distance.
Equal to the distance. Let me put D to show that this is the distance. So this is our distance here. So this is our distance right here. So what we are saying is that the difference between the radii, which is what I have here, is still equal to the distance. Get my equal sign. So when the two circles are internally tangent, you can see that the difference between the radii of the bigger circle and the smaller circle equals the distance between the centers of the two circles. Now let me explain my terms. We have r equals the radius of the longer circle. This capital letter R equals radius of the longer circle, and this R, small letter, is radius of the smaller circle, and then D is the distance between the centers of the circles. Now we have this relationship between the two circles. What do we call the relationship between these two circles?
Intersecting or secant.
Intersecting or secant. So when we have two circles secant like this, we want to find out the distance between the centers of the circles. This is the distance between this is the center of this bigger circle and the center of this smaller circle. Let's firstly identify the radius. Where is the radius of the bigger circle? Show me the radius of the bigger circle. Okay,
Pink.
The pink one. So I'll put that as R to show that it's the radius of the bigger circle. What about the radius of the smaller circle?
The white.
The white one, the radius of the smaller circle. So I'll put that as small letter R. The radius of the smaller circle. Okay, now the radius of the smaller circle. Now look at the center of the smaller circle here and the center of the bigger circle here. We want to look at the relationship between the distance of the two circles and the sum of the radii of the circles. So I'll use something to mark my distance. The center of this circle and the center of this circle. So this is my distance. I'm using this to represent my distance. Can you see the distance between the center of this circle and the center of this circle? This black strip. I'll put that as D. Okay. So I want to see if I use my distance as my first term of comparison. Is the distance bigger than or greater than, less than or equal to the sum of the radii? Let us see. I'll do something for you to see. So we are saying the sum of the radii. Let's get the radii out. So put them together.
Yes.
Okay, so I'll get mine. This is the radii of my small circle. Let me take it. And I'll remove the radii of my small circle. I'll put it here. This radii of my small circle. Let me get the radii of my bigger circle. Before then, let me take the distance. Oh no, let me get the radius of my. Okay, try to get the radius of my bigger circle. This radius of my bigger circle. I want to put them together. Can you see? This is R plus R. That's the sum of the radii. Now look at the distance between the two circles. These are distance. So from what you have seen, when the circles are secant, as we have seen, look at the distance, the sum of the two radii, R plus R. How does it compare? Let me make my distance my first term of comparison. Is the distance between the centers of the circles less than or equal to or greater than the sum of the radii?
Less than.
The distance is less than the sum of the radii. So D is less than the sum of the radii, just as we can see here. That is when they are intersecting or secant. Let me define my terms. R equal to the radius of longer circle and this small letter R equals radius of shorter circle, and D the distance between the centers of the circles. When the circles are secant. Now suppose I make the sum of the radii my first term of comparison. When the circles are secant, is the sum of the radii greater than, less than, or equal to the distance?
The sum of the radii equals.
Look at it. Look at the sum of the radii. That's these two strips together. This is the radius of the bigger circle. This is radius of the smaller circle. So my question is this and this plus this? Let me put plus. Let me put plus so you know. Look at the sum. This pink one and this white. This pink one is the radius of the bigger circle. The white one is the radius of the smaller circle. So my question is, if you put these two radii together, this is the bigger radii and the shorter radii, or longer radius and the shorter radius. Put them together as we see them here. Compare it with this distance between the centers of the circles. Which one is greater? Is this greater than this or less than this?
Greater.
You can see right there is greater. That means the sum of the radii is greater than the distance. So if I make this my first term of comparison, I'll say that the sum of the radii of the bigger circle and the smaller circle is greater than the distance. greater than the distance between the circles when the circles are intersecting or secant. Okay?
Yes.
Look at these circles. What can you say their relationship is?
Internal or centric?
Internal or concentric?
Concentric.
Okay. So, internal or concentric. So now you can see the radii, the radius of the longer one and the radius of the shorter one. Look at the centers of the circles. Look at the center. The center of this circle is here. The center of this circle is here. So what can you say about the distance between the centers of the circles when they are internal or concentric?
There's no distance.
There is no distance. Both circles have the same distance, right? The distances coincide.
Yes.
Okay. So I'll put it like the distance equals 0 when the circles coincide. I mean when the circles are internal, where D is the distance between the centers of the circles. See, there is no distance. Both circles have the same center. So the centers of the two circles coincide when the circles are concentric or internal.